Hi, welcome to Ashok Kumar channel Physics. Today we are going to discuss about a new topic about the refraction of light. So just we will recall the properties of light. What is a light? Light is an electromagnetic wave, means it does not require a medium. Even without medium also it can travel. That is about the electromagnetic wave. Light is an electromagnetic wave. As we are discussing about ray optics, light is having a dual nature. It has a straight line nature and it has a wave nature. So now in this refraction of light, we are going to discuss about the straight line nature of light. That means we will take light always travel in a straight line. That means light energy is carried in a straight line. And next one, light always travel from object to observer. Okay. And next, if there are more than one path is available for a light, so it choose the path which takes less time. And light causes sensation of vision. If there is a light, you can see the objects. Light will cause a sensation of vision. These are the properties of light. And next, what do you mean by the refraction? When refraction happens, so as we have seen in the ninth class, reflection, if a light is coming from a medium towards an opaque object, important one is opaque object. If a light is coming towards the opaque objects does not allow the light into them, so that they are going to reflect the light into the same medium from where it is coming. If a light is coming from the air towards the opaque object and reflect back to the air, that means there is only one medium is involved in the reflection of light. But in the place of opaque medium, if you place a transparent medium, that is like a water or a glass, which is not a mirror, glass, we are talking about the glass. So if you place a glass in the direction of the light ray, then light travel into the glass. Glass does not reflect the light. Glass will allow the light into it. Water will allow the light into it. So that means those objects which will allow the light into them, those are said to be the transparent mediums or transparent objects. So light can travel from one medium to another medium. That means it can travel from one transparent medium to another transparent medium. There is no opaque mediums here. So always we are talking about the transparent mediums. If a light is traveling from air to glass, it can travel from air to glass. It can travel from air to water. It can travel from water to glass. It can travel from glass to water, because all these are the transparent mediums. So light can travel from one medium to another medium only when the mediums are transparent mediums. If there are two transparent mediums we are having, but in the reflection of light, there is only one medium is involved. From which medium the light falls onto the opaque object, it reflects back into the same medium in the reflection. There is no involvement of second medium in the reflection of light. But in the refraction of light, there is involvement of two mediums. Because if there are transparent medium, if this is a medium 1, a transparent medium, you can assume this one as air. Air is a transparent medium. And another one, you can assume this one as medium 2. You can assume this one as water. Water is also a transparent medium. You can assume this one as air, this one as water. Or you can assume this one as water, this one as glass. Either way you can assume. But generally, this is one transparent medium, this is another transparent medium, I am assuming. Now the light. Light can travel from this medium to this medium because both are transparent mediums. So if a light travels from one medium to another medium, as the medium changes, that means the property of medium changes. What happens to the light? Is there any effect to the light if it is traveling from this medium to this medium? Is there any effect? Yes, definitely there is an effect. What is that effect? So velocity is going to affect when the light, velocity of light is going to affect when light travels or when light goes from one medium to another medium. So which physical quantity of light is going to affect when it travels from one medium to another medium? Velocity is going to affect. Why? Because in this medium there may be more gap between the particles. Suppose if this one we are considering rarer medium, this one is said to be denser medium. Rarer medium is nothing but the gap between the particles is more. Suppose if the gap between the particles is more, so the light can travel without collision in the rarer medium. But if you assume this one as a denser medium is nothing but particles are close to each other, then the velocity of light is going to collide with those particles because the gap is very less. So the light ray can collide with those particles. As it is colliding, its magnitude, speed is going to change, and when collision happens, direction is also changing. Speed changes and its direction also. Speed which is having a direction, we will call that one as velocity. So finally, we are saying that velocity of light is going to change. Why the velocity is changing? Just the velocity of light is changing because medium is changing. That is a property of nature. Nature is changing. This medium is having one nature and this medium is having a different nature compared to this one. That nature which can affect the velocity of light, that is said to be the refractive index. So this medium is having a refractive index and this medium is having another refractive index. Because of the refractive index changes in the direction of light, velocity is going to change. Now we can write the refractive index. What do you mean by the refractive index? Refractive index is all about nature of medium. The nature of medium which can affect the light. This medium nature can affect the light. This medium nature can affect the light differently. So different medium natures affect the light differently. That nature is called a refractive index. So generally we will denote with mu, or sometimes we can denote with n also. Okay. So then what do you mean by the refractive index? So refractive index, it is a nature of medium or property of medium. You can call anything. It is a nature of medium. Nature of medium or property of medium. What this nature will do? This nature will affect the velocity of light. So it is the nature of medium which will affect the velocity of light when that light is coming from another medium which is having another refractive index. So main source of change in the velocity is the collision of the light with the particles of the medium. So the size of the particles may be different, so the effect in the velocity of light is also going to differ. So now this is the refractive index. We are having two types of refractive indexes here. So and if that is said to be absolute refractive index and relative refractive index. Before going to that one, how this refractive index changes the velocity. So refractive index changes, velocity is going to change. This medium is having a refractive index, I am taking as mu1, and this medium is having a refractive index, I am taking as mu2. Okay. If nature is more, that means if refractive index is more, then it can affect the velocity more. That means as there is more effect, then collisions are more, that means velocity of light is going to decrease. That means as it is having more refractive index, more nature, that nature will affect the velocity. So this is said to be denser medium. If you take this one is the denser medium is nothing but optically denser, not mass denser. So here we are considering optical related to the light, not related to the mass. So this is said to be optically denser medium. Optically denser medium is nothing but when you compare these two mediums refractive index, Which medium is having more refractive index? That is said to be the denser medium. By comparison only we can say which is denser medium and which is rarer medium. So if you compare this medium refractive index with this medium, if it is having less refractive index compared to this one, then it is said to be the rarer medium. Rarer medium and denser mediums. Finally, we will compare them. So we can say which is rarer medium and which is the denser medium just by comparing. Okay. So rarer medium is nothing but having less refractive index compared to this medium. And denser medium is nothing but having more refractive index compared to this medium. Okay. So as it is a denser medium, it can affect the light heavily. So velocity is going to decrease in the denser medium. So which is having more refractive index. As the refractive index is more, then it can affect the velocity of light more. That means as it is affected more, velocity of light is going to decrease. So this is a relation how the refractive index affect the velocity of light. As the medium is having more refractive index, in that medium velocity of light is less. Okay. And you are having two types of refractive index. One is the absolute refractive index, another one is relative refractive index. Absolute refractive index, another one is relative refractive index. What do you mean by the absolute refractive index? As we have seen, the light is traveling from one medium to another medium. If the first medium is a vacuum, definitely it must be vacuum. If this medium is a vacuum and this is another transparent medium, light is traveling from vacuum to medium, definitely it must be like that. So then refractive index of medium when compared with vacuum, refractive index of the medium when compared with vacuum, comparison compulsory. So refractive index of medium, in which medium light is moving, second medium, in to which medium light is moving, that medium. Refractive index of medium, from where it is coming light, from the vacuum, definitely it has to come from the vacuum only. So refractive index of medium, refractive index of medium when compared with, refractive index of medium when compared with refractive index of vacuum, refractive index of medium when compared with the refractive index of vacuum. Vacuum is nothing but there is no air at all, even there is no air. Okay. Refractive index of medium when compared with refractive index of vacuum. So vacuum refractive index generally we will take that one as 1. So refractive index of medium, you can write this one as refractive index of medium, this is medium, when compared with the refractive index of vacuum. So why do we have to compare? Because velocity is going to change. As the refractive indexes are changing, then velocities are also changes respectively, inversely related. So then, and they are inversely related. If it is the refractive index of medium in the numerator, then you will get velocity in the medium, in that medium, you will get in the denominator. And the refractive index of vacuum is in the denominator, then you are going to get velocity of light in the vacuum, you will get here. And the velocity of light in the vacuum is a constant, which is 3 into 10 to the power of 8. We can call that one as C, where C is nothing but velocity of light in the vacuum. So in the vacuum, velocity of light is 3 into 10 to the power of 8 meter per second. This is always constant. And the refractive index of vacuum is always 1 we are taking. Then you will get a refractive index of medium, just if you can assume that one as a mu. Refractive index of medium is mu if you assume, and the refractive index of vacuum is 1 is equals to c, and velocity in that medium if you take as v, then it is mu is equals to c by v. This is the formula for absolute refractive index. Generally, this refractive index of vacuum, which is equals to 1, we can take that one for air also. So there is a slight change between the vacuum and air, but we can take this one for air also. Refractive index of air also we will take the same, which is 1. Okay. So based on this one, you can write, you do have a problem. So manaki din meeda oka problem undu. What is the problem? Suppose if you are given light is traveling from, if you are having any doubts, you can take a screenshot and the definitions. Okay. So now, how do you get the problem based on the absolute refractive index? Suppose if you are given a light is traveling from air to the medium which is having a refractive index 1.5. So here light is traveling from air to another transparent medium, air to a medium which is having a refractive index, which is having refractive index mu is 1.5. Then what is the velocity of light in this medium who is having refractive index mu 1.5? Then what is the velocity in this medium? You need to find out. So then find velocity of light in the medium. Find velocity of light in the medium. How do you find out? So as it is traveling from air to medium, that is you can take from vacuum to medium. So as it is traveling from air to medium, then you can take the absolute refractive index, which is mu is equals to c by v, where c is having the value which is 3 into 10 to the power of 8 by, you need to find out velocity in this medium which is having a refractive index 1.5. You need to find out this one, which is equals to mu is equals to, how much is the mu here, which is 1.5. So then 1.5 will get here. So then 15 ones, so 15 twos, 1.5 into 2 is 3. Then velocity in the medium is equals to 2 into 10 to the power of 8 meter per second. So air is having a refractive index of 1 and medium is having a refractive index 1.5, and air means refractive index increases from 1 to 1.5. This is having a refractive index 1. Air is refractive index is increasing from 1 to 1.5. Then velocity, as the refractive index increases, velocity is going to decrease. That is what we said previously. Refractive index increases, velocity decreases. In the air, it is having a velocity which is 3 into 10 to the power of 8. As the refractive index increases, what happens to the velocity? Decreases from 3 into 10 to the power of 8 to 2 into 10 to the power of 8 meter per second. So this is about the absolute refractive index. And next, relative refractive index. Likewise, you are having different problems. So in some problems, you are going to give the velocity in the medium and you need to find out the refractive index. Then mu is equals to c by v. Directly you can take. There are different problems. Suppose if you are given light is traveling from air to medium. light is traveling from air to medium. That means which is comparison of refractive index of medium with air, which is absolute refractive index. So air to medium. So in the medium, its velocity is 2 into or 1 into 10 to the power of 8 meter per second. In the medium, its velocity is 1 into 10 to the power of 8 meter per second. Maximum velocity of light is 3 into 10 to the power of 8. So more than the 3 into 10 to the power of 8 velocity is not possible, because maximum velocity is 3 into 10 to the power of 8. When it enters into the medium, it is traveling with a velocity 1 into 10 to the power of 8 meter per second. Then find out refractive index of medium, that is mu of medium. Mu is nothing but a refractive index. You need to find out the refractive index of medium directly. You can take mu is equals to C by V. C value is 3 into 10 to the power of 8 meter per second, and V value is velocity in the medium is 1 into 10 to the power of 8 meter per second. Meter per second is going to get cancelled. Refractive index does not have any units. Why? Absolute refractive index does not have any units. Why? Because this is velocity by velocity. Units are going to get cancelled. That's why we can say absolute refractive index is a unitless, dimensionless, physical quantity. It is a physical quantity, but it does not have units, because it is velocity by velocity. Units are going to get cancelled. And here 10 power 8 is also going to get cancelled. Then how much you are going to get? Mu is equals to 3. All the mediums are having the refractive index more than air, more than 1. 1 is the least refractive index. And the remaining mediums are having more than 1 refractive index. So the least refractive index is for vacuum, and also we can take for the air. As refractive index increases from 1 to 3, velocity is going to decrease from 3 into 10 to the power of 8 to 1 into 10 to the power of 8. As the refractive index increases, velocity of light is going to decreases in that medium. So these are the some example problems related to the refractive, that is absolute refractive index. So now you are having another type of refractive index, that is relative refractive index. If light is traveling from one medium to another medium, there is no involvement of vacuum there. If light is traveling, in the previous problems we have seen light is traveling from air to medium. If air is not involved in the direction of light, that means if a light is traveling from water to glass, it can travel. Water is a transparent medium and glass is a transparent medium. Light can travel from water to glass. There is no air there. Then that type of refractive index, when we are comparing one refractive index, one medium refractive index with another medium refractive index, which is not vacuum, that refractive index is called a relative refractive index. Here, there should be no vacuum or no air is involved. Air can also involve, but that relative refractive index is called absolute refractive index. If air is involved, then the comparison of medium refractive index with air is called, that relative refractive index is called absolute refractive index. If air is not there, so then refractive index of one medium, refractive index of one medium compared with, you can compare with the air, but that relative refractive index becomes absolute. So refractive index of one medium compared with refractive index of another medium, then this type of comparison of refractive index is called a relative refractive index. So why we need to compare? Because velocities are related with the nature of the mediums only. If you compare the refractive indexes, then you will get the how many times velocity is going to decrease or how many times velocity is going to increase. You will get by the comparison. By comparing refractive indexes, you will get how many times velocity is going to increase or how many times velocity is going to decrease. To get that relation, to get how many times velocity is going to change, you need to compare the refractive indexes. So refractive index, now I am comparing refractive index of medium 2 with medium 1. So refractive index of comparison of refractive index of medium 2 with medium 1. This is the indication. This says that this is said to be refractive index of medium 2 with respect to medium 1, which is with respect to, always you will get in the denominator. This is said to be refractive index of medium 2 with respect to medium 1. Then you will get the velocities relation. Velocity is inversely related to the refractive index. As here is the mu 2, then you will get a v2 here, and mu 1 is in the denominator, then you will get a v1 in the numerator. So to get this relation, you need to compare the refractive indexes. It must be there. In order to get the velocity relation, you need to compare the refractive indexes. So this is said to be refractive index of medium 2 with respect to medium 1. You can compare in the reverse way also. You can compare refractive index of medium 1 with respect to medium 2. So that is refractive index of medium 1 when compared with the refractive index of medium 2. This is nothing but mu 1 by mu 2. Here we are comparing medium 1 with respect to medium 2. You can write this one as 1 by mu 1, mu 2 by mu 1. You can write this one as mu 1 by mu 2. You can write as 1 by mu 2 by mu 1, which is nothing but 1 by mu 2 1. This is mu 2 by mu 1 is nothing but mu 2 1. And you can write this one with the velocities. Here is the mu 1, then you will get velocity here is in the denominator. It is mu 2, then you will get in the numerator. Then mu 1 2 is equals to this one. 1 by mu 2 by mu 1 is nothing but mu 2 1. You can write this one as mu 2 1. If you multiply them, mu 1 2 into mu 2 1, then you are going to get this one as 1. This is important one also, and this one also. Refractive index of medium 1 with respect to medium 2 is equals to reciprocal of refractive index of medium 2 with respect to medium 1. Okay. So this is about the absolute refractive index and the relative refractive index. Okay. So here also you will get the problems. So you are going to give the refractive indexes of the mediums, refractive indexes of mediums. If you are given, then you need to find out the velocity in any medium. Okay. Now it is very important for us also. When refraction happens, velocity is going to change. When light is traveling from one medium to another medium having different natures, its velocity is going to change. As the velocity changes, wavelength of light is also going to change. So because we are having the formula V is equals to n lambda, the frequency of light, frequency is nothing but source. From the source, so with whatever the frequency it has released, it moves with the same frequency in another medium also. Frequency is constant, then velocity is directly related with the lambda. That means as the velocity increases, wavelength also increases. As velocity of light decreases, wavelength of light also decreases. You can write this formula as V2 by V1, and it is directly related with lambda also. You can write this one as lambda 2 by lambda 1 also. You can write this one as lambda 1 by lambda 2 because velocity and wavelength are directly related. Okay, but refractive index is inversely related. Mu 2 by mu 1 is equals to V1 by V2 is equals to lambda 1 by lambda 2. Okay, so this is about the relative refractive index. So here we said about some basic information about mediums. If a light is traveling from one medium to another medium, what happens? Velocity of light is going to change. As velocity changes, wavelength also changes, but frequency is constant. So this is very important question for you also. In the refraction, which physical quantities of light are going to change? Which properties of light are going to change in the refraction? So we can say velocity changes. First of all, velocity compulsory change because the collisions happens. So different mediums offer different collisions. Okay. So as the velocity changes, according to this formula, wavelength also changes. That means velocity and wavelength of light is going to change when refraction occurs. But which is constant in the refraction? So the constant one in the refraction is frequency. But in the reflection, with whatever the velocity it is coming towards the opaque object, it moves with the same velocity. Okay. So in the reflection, velocity of light will not change, and wavelength also not changes, but which is changing in the reflection means phase. So what do you mean by the phase, you will get in the next classes, but not here, which is not important here also. Okay, this is about a relative refractive index, absolute refractive index. Now we need to explain this one. Until now we haven't explained what is a refraction. Okay, so just we are discussing about the nature of the mediums, how the velocity is going to affect because of the nature of the mediums. Okay, so now we need to explain what do you mean by the refraction, sir. So refraction is nothing but as the velocity changes, what happens to the light direction. So according to Fermat principle, so light has to choose a path which takes less time. As the velocity changes, it chooses the path which takes less time. That means it chooses another path. If a light is moving not in the direction of normal, at an angle to the normal, if a light is incidenting towards the interface which is dividing the two transparent mediums. So if a light is entering at an angle to the normal, this is the point of incidence. At the point of incidence, if you draw the normal, this is the normal which is perpendicular to the interface. This is the incident ray and this is the normal. The angle between incident ray and normal is called angle of incidence. Okay. Suppose if it is the rarer medium and if it is the denser medium. Okay. Rarer medium means nothing but having less refractive index and more velocity of light in that medium. Denser medium is nothing but having more refractive index and velocity of light is less in this medium compared to that one. Okay. So when light is traveling from one medium to another medium, its velocity is going to change compulsory because medium properties changes, refractive index changes. This is the original direction. If there is no involvement of another medium, this has to travel in that direction. But as there is another medium is involving, as the nature is changing, it is going to divert, it is going to change its direction either in this direction or in this direction. From the original direction, it has to move in this direction or it has to move in this direction in order to take less time path. So then, if it is traveling from rarer to denser, it is going to bend towards the normal like this. If it is traveling from denser to rarer, it is going to bend away from the normal. We will explain them in the next class. But now, just we are explaining about what is the refraction. So this bending of light, where it is bending at the point of incidence. This bending of light from the original direction, this must be the original direction. From the original direction, the light ray is going to bend either towards the normal or away from the normal. That bending with respect to normal from the original direction is called refraction. Now we can write the refraction is refraction definition. Whatever the concept we are knowing, we are writing the definition according to our concept. Okay. So what is the definition? Definition is you can write on your own. There is no perfect definition. If you are having the perfect concept, then you can write your own definition. So refraction is nothing but bending. Light is bending from where? Bending from the original direction. Bending from the original direction. Bending of light from the, there must be light. Bending of light from the original direction with respect to normal. That means it can bend either towards normal or it can bend away from the normal. That is with respect to normal. Why? As the light is moving from one medium to another medium. When light is traveling, when light is traveling from one medium to another medium. As it is traveling from one medium to another medium, its velocity is going to change. That's why it is changing its direction. So when light is traveling from one medium to another medium, as the velocity of light changes, that is said to be refraction. Refraction is nothing but bending. Reflection is nothing but bouncing back. That is said to be reflection. And refraction is bending. Bending from the original direction. Where it is bending? At the point of incidence. Bending from the original direction with respect to normal at the point of incidence when light is traveling from one medium to another medium as the velocity of light changes. This is said to be the refraction. Now we have completed the basic information about the refraction. Okay. In the next class, we are going to discuss about the rules, how the images forms because of the refraction. When refraction happens, how do you get the images? When it is traveling from rarer to denser, how do you get the images? When it is traveling from denser to rarer, how do you get the images? So we will form some rules. Based on the rules, we will get the images. Okay, thank you for the class.